on this gray dashed line in the middle. And in the inlay graph, so that's the one with the gray dots and the black line, we have the same without logarithms, but that makes the interpretation of the scale a bit more difficult. But what we can say from this is that both of these diagrams point towards a meaningful relationship between production prices and market prices. The deviations, they exist, but there's clearly a regulating pattern between production prices and market prices. It's almost linear, much like the Marxist labor theory value would prescribe. The relationship can also be tested in a panel regression setup, which is essentially correlation analysis with more sophisticated means. And here now, a strong relationship between production and market prices, or direct price and market prices, or production price and direct prices, would have, let's say, a beta coefficient, a slope close to 1, an alpha intercept close to 0, and an R squared close to 1. And on the right-hand side here, I reproduce table 3.2 from our book. So you can also, again, look it up in the book if you'd like. And here in the left column, we have the relationship between market prices and production prices. We have an insignificant intercept, much as we predicted. We have a slope coefficient that's extremely close to 1. And we have an R squared that is essentially 0.9878, very, very close to 1. So again, we find empirical evidence that labor values are very good predictors of market prices, and production prices are really good predictors of market prices, and that indicates a meaningful relationship. For completeness, we can also measure deviations as distances in the vector space. So the popular choices for that is either the mean absolute deviation, MAD, the mean absolute weighted deviation, MAWD, the coefficient of variation, CV, or the Euclidean distance, D. These calculations right now add little more value to our question, but they help tie to the literature, where they're very popular, and they also enable it to assign a single distance value to each industry, to each country, to each year. So if we want to start investigating the distances and deviations, then this is going to be really useful. The math behind it, as you can see, is simple but lengthy. These are longer formulas. But let's just say the results show that also in this dimension, labor values are really good predictors of market prices. And that indicates a meaningful relationship. So what I showed up until now is that if we operationalize this key component of Marxist value theory, then we can also test its central propositions. And our investigation and the broader literature, which we'll find later in the slides, again in this tiny font size, we find a plethora of empirical evidence for the idea that labor values regulate market prices, and the profit rate equalization expressed in production prices play a key role in that regulation. And next, I promised an application. I'm gonna take a sip of water here. Okay, I spent now 40 minutes to explain, let's really say, the theoretical foundations and empirical techniques behind our workhouse model, right? The workhouse model of direct prices, production prices, and market prices. And in that span, we have now, over the questions that we asked ourselves, built a database that spans 25 years, 44 countries, and 5 rest of world regions, and more than 150 industrial sectors. It is the largest of its kind as of now. At the same time, it can also be extended to a 216 country base if we accept the implied weaknesses in data collection and the unavailability of some key variables, such as fixed capital stock. But maybe more importantly, for the next question to come for the application, is that it can be combined with other data sources. We've combined it with data on multinational enterprises, financial payment flows, and what I will present now is the combination with land use and resource extraction. In this application, we will analyze the global role of ground rent based on Marxist value theory. And this is a key moment here, because by estimating ground rents from values rather than from land size or something else, more precisely from the market production price differentials as extra profits, it allows us to estimate ground rents independently from land valuation, and without using techniques like instrumental variables or other causal methods. This is only possible because we ground this application in the overarching value theory. And this again brings us back to theory for just a bit. Ground rent is tied to the fact that land is used like capital in production, but it's non-reproducible. And this non-reproducibility really is the key to ground rent. Because on the other hand, the reproducibility of capital is the key for the establishment of a general profit rate and therefore for production prices. Capital, both in its physical expression, so that's machinery or energy or whatever, but also in the social relation, where workers expend labor power in production, but they don't own their own product, will be reproduced because other capitalists can invest in the same sector if they see profit rates that they like, that are higher than the normal, and thereby push the price and the profit rates back to the normal case, right? But in some cases of capitalist production, this does not hold true. The classical case that was discussed by Adam Smith, David Ricardo, and Karl Marx, and many, many others, is agriculture. But Marx makes it perfectly clear that the same principle applies to any landed property. Let's think here of mining, of extraction, and energy production from rivers, anything landed really. As long as one firm on landed property gains above normal profits, wherever they come from for the moment, then other capitals cannot easily enter the market and imitate their production techniques. Right? So they cannot drive down market prices to production prices, and they cannot drive down the profit rate to the general profit rate. This does not mean that landed property can realize any price that they want, of course. They're limited by demand, by available alternatives to the commodities, and an investment still happens either through offers one cannot refuse because they're too good to refuse, right? Or by share buying in financialized agricultural companies and conglomerates. Nevertheless, production on landed property can realize extra profits. And these extra profits are tied to the type of land, of capital, the type of capital that they apply, which is land. And this is why we call it ground rent. Now, ground rent, we have to understand, is not a property of land. That's what Ricardo would say, or Adam Smith would say. So this is the income that comes from land. It's not. Ground rent, for Marx, is an expression of the social relation where land is on the one hand treated like capital, but it's not treated like any other capital because it is restricted socially. Not everybody can have it because there's either a limited supply of it or because there are social norms that restrict using it. And now with land, it's a bit difficult because we can haggle. Is really all land fertile? Can we use all land? Vertical farming, is that an option? But let's take another example. Proprietary data has no physical properties whatsoever, but it will give a firm a competitive advantage if and only if it is protected by the social norm of intellectual property rights. They can go down over time, but they're established socially and capitalists can exploit them as rent. Now, when it comes to ground rent, we distinguish between three types of rent. We have absolute rent that's realized by any producer that is on landed property. We have differential rent of the first type that express differential fertilities of land. So let's say an oil well that is above a large reservoir will just extract more ground rent than an oil well that's over a tiny reservoir because they get more oil out of it. And then we have the differential rent of the second type, which is what happens when producers use more capital to make up for fertility differences. For example, a faster pump on the oil well, or investing into searching for a deeper reservoir under it, as long as this capitalization has a lasting impact on the land used. So think here maybe of draining swamps for agricultural use. Once you drain a swamp, the fertility of the land is much higher for a long period of time, even if you dig no further troughs or install no new pumps, right? This is a schematic sketch of that. So monopoly and absolute rent will be earned on the difference between market prices and production prices if market prices are persistently above production prices, and differential rents will be earned on a single capital's production price and the general production price. And as you can see, these will not cancel out to zero. They will add up and we will measure them together. Right. So what data do we have? Again, Excel basis satellite accounts. Satellite accounts are just all data beyond industrial payment flows in the input-output tables. They distinguish between 15 categories of land use and resource extraction. Some of these land uses are tied to only one industry. So we mashed them together in 9 categories: forest land, cropland, other land, pasture land, coal, gas, oil, metallic ore, and non-metallic ore extraction. And what you can see in this summary table here is these are the market price, production price differentials in the 3rd column. And you can see that in total, they are very, very small. They're almost zero for on average for all industries. But once we start distinguishing by land use and extraction, then almost all industries that have land use have persistently higher market price than production prices, and those who don't use land and resource extraction have lower ones. This also gives an indication who pays for ground rent. That is all the other industries that buy circulating capitals from the landed properties. The exception here is, of course, metallic ores for now. I also illustrated this in a simple density plot. The dark line here shows market price, production price differentials for industries that have no ground rent or no landed property. And you can see it's really narrow and it's really centered around the 0 line. And here on the right-hand side, you see cropland, which almost all industries are shifted strongly to the right, getting extra profits out of it. Right. So we can now calculate land use per industry, but only on the aggregate industrial level. And this means it is impossible for us to distinguish between absolute and differential rent in the data. So we do calculate total land use and correspondingly total positive and total negative rent payments per industry. Let me skip that because I think I'm slowly running out of time here. What we do now is we construct 3 sets of market production price deviations on extraction data for land using or resource extracting industries, for producers that directly process them, so think of food production here, and from downstream capitals, think of restaurants as this. We call them E0, that's direct land use, E1, direct processing, and E2, that's downstream use for simplicity. And just on the last line of the slide, you see that we can again estimate a panel regression with market production prices as a dependent variable and then extraction as the independent variable. And then we can just multiply the coefficients with actual gross production, market prices, and that gives us aggregate estimates for ground rent. Now, the econometric regression finds 3 interesting features. So in the first column here is 0. We see these land use resource extraction coefficients and where they are significant, and that is for forest land, cropland, gas, oil, and metallic ores. They're positive. The exception is pasture land here, where it is negative but very, very small as compared to the others. In direct processing, so that's the second column, the coefficient is negative for agricultural use and for coal, but it's positive for gas, oil, and metallic ores. And positive ground rents are offset and more than offset, I will speak about it in the end just a tiny bit, by negative profit penalties for gas, metal, and non-metallic ores. This gives you the distribution of between industries of aggregate ground rents. It's intuitive, I think. You cannot read it from the figure, but on the left-hand side, you have agricultural and mining industries. They receive ground rents. In the middle, you have some manufacturing industries that receive processing ground rents, but they pay for energy and resource use. And in the right-hand side half, really, you have all further manufacturing and service industries that pay profit penalties for using energy and processed goods. Now, this figure gives you the distribution between countries. This is way less intuitive. Interpretation is way more difficult because now within each country, we mesh together some industries that receive ground rents and some that pay ground rents. But just on the aggregate, we can see is that those industries that receive large ground rents, which is the brighter gray bar here, for China and the United States, for example, they also pay for energy and resource use. And in the case of the United States and China, also the massive import of foodstuff. In total, then we calculated, of course, these ground rents, and we found that they're really economically significant. So every year, 1.1% of gross